It's really an honor to be here and to speak to such a large audience, which is a serious audience, and I hope that you will enjoy what we are going to present to you. We have the topic is about interaction with AI, and on a large scale. If this works, no, it isn't. No, it isn't. Not yet. But then we can just. Okay.
Try again.
Next slide, please. Yeah, there it works. Okay, great. Okay, so, but sure to land, you all know and you are all familiar with many projects that you work in many domains. And in many domains, we interact with AI and AI applications. For example, on the left side, you see medical applications. Then, for example, in a factory, for manufacturing situation, there are machines that do the planning and suggest when something is going wrong on the shop floor. They can communicate with the planning systems. Not that humans are not there, but humans and machines work together in manufacturing. Shipping, containers, safety, so drugs and weapon transport. The customs in the harbor, port security, they know sometimes which containers to pick out for further inspection, but not all containers can be inspected, and sometimes you use systems to make that selection a little bit easier for you. And there are many systems in the ports and the harbors, but humans and those systems collaborate and work together to make that proper decision making and try to find the maximum. And the last one, last but not least, this will be the talking building scenario and the project that we are going to dive in a little bit further with Mansour. That's where each building can run its own efficiency algorithms for energy management, but maybe to reduce peak loads on the grids, it's better that the buildings communicate with each other. So in the project Talking Buildings, we do this AI that is not only on an individual basis learning to optimize things, but also in collaboration. Collaboration with the buildings and collaboration with building owners or engineers. We come to that in a minute. Then to further talk a little bit where we're about, there are many interfaces, different types of interfaces that we use for that interaction. Of course, the ChatGPT, but also the watches that you have from all these smart running applications. And maybe, and if you look carefully, you see a mental health application where people can get advice to systems to support themselves when it comes to support that is needed for mental health. But actually, it's not only these screens that we are using to. Maybe lots of you this morning sit in public transport with earbuds and other devices that help us throughout the day, either for entertainment or for the calls that we have to make. These same interfaces can be used with voice support, for example, in mental health, that support people when they have a certain anxiety, for example, when you have to go through crowded places. You need a little bit support for that. So the AI interfaces are not only screen-based. That's important because it's about what it does with the mind, with your perception. And that is actually where a lot of interaction principles and design will be important. How does it influence the things that we want the AI to do for us? How can we team up? You see a cube. For the many types of projects that we do, not only for ourselves for road mapping, but also for customers to explain about their expectations, we say, okay, their current AI system can be in one of those tiny cubicles. And this helps them to find a way like, okay, what will that AI do for us? I'll take you through these 3 dimensions to further explain. For example, you want to know, is this now a tool or is this something that can be regarded as a companion? You have these levels of autonomous driving. These are 5 levels. And based on that also, we deliberately chose 4, not to sit in the middle each time. But then we say like, okay, maybe this is a human-trusted application. You just go and you press a button and then an optimal treatment plan comes out, for example. Or you have autonomy in that you say, okay, we believe in the algorithm of this building. It can manage itself when it comes to that climate management problem. can it be turned on heat or cold or whatever, but you can trust the building maybe on that. So there can be an axis to classify your own project along this axis of agency. The second axis that we use is like, okay, does the AI talk only about its task? Am I done? Can I do faster? Was it okay? Or is it more like, this is the way that I learned to do it optimized? So in learning and co-learning settings, these algorithms, sometimes embedded in agents or physical machines, they can communicate about their learning process, co-learning. And if you go a little bit further, the talk in camera 4 just mentioned Netflix about giving suggestions to the users. And when you collaborate, and you see that when you collaborate with human colleagues, you share experiences and suggestions with each other. So you could go up to a level like, oh, if I were you, that's that mental modeling aspect. We are moving up into there with the AI that tries to, well, take a part of your brain and does a suggestion as it was you and give you the best suggestion on that. And maybe it's then even more motivating and can be done to manipulating, or that's the thing. You do not have to be always to the right side. That's not part, but you can do classify your AI project. So for that, it helps from going from a situation where you can be with a customer and where you want to go with them. Or if somebody says, yeah, but why isn't it do like this? Well, then you can help him like, okay, normally we are there, but if you want to have other expectations, maybe you have to improve it a little bit. And you can just explain alongside these axes where the next version of your AI application would go to. Well, and then we had that slide of these 2 dimensions, and the third dimension then came in, which was about, does it impact yourself with a little tool? How complex it is, it doesn't matter. Or does it help your organization? Or even, does it help your branch, the branch of organizations? And if it goes to the branch, then it's more to the right side. And even you can go further. Sometimes we have these winning AI applications that indeed change our society. Again, not every application has to change society, but to think about the impact, you do that when you design these interfaces. So we use this cube to think about interfacing of the Talking Buildings project. And I think that it's fair to Mansour to explain us a bit what we designed and what design choices we made. And maybe you can take that also for yourself in your own project. Mansour, that's for you.
Thank you very much for this nice introduction of the AI maturity, interaction maturity model. And indeed, I'm going to present, well, one of the projects that Vico and I are working on is AIMS. And in AIMS, we are trying to build buildings equipped with AI, basically smart buildings that are optimizing for energy usage or maybe CO2 emissions. And one of the challenges that AIMS is trying to solve is to scale up quickly so that it can have a higher impact on maybe a country level or maybe a worldwide even. You can think of a lot of interactions that are possible within the building between humans and the building management system. For example, a human can say, oh, it's too cold today. So the building management system can react to the feedback and hence increase the temperature. Or there could be an interaction between the owner of the building and the AI. So the owner may inquire, oh, why is my bill today so high? And the AI can provide some insights. Oh, this has happened, you have increased your heating and so on. And maybe the building owner could also ask for, oh, is there anything wrong? Or maybe the AI could actually talk to the owner and say, oh, you have some CO2 increase. What happened here? And then the person can actually look into it more and then work off from that. But today we're going to focus on a very specific task of actually configuring a new building. So once AIMS has a new client, usually a BMS operator, so that's from AIMS, goes to the owner of the building and asks for something like a building schema. A building schema is basically a representation of how the building works, or what sensors there are, how are they all connected, and so on. And it is actually quite challenging. Let's look into it a bit more. So first of all, as a BMS operator, you have to know specific knowledge, a specific lingo that is used in your domain, right? And different companies also that set up the BMS systems have usually different notations for stuff. So you need to be quite educated to actually be able to set up a new client. Sometimes the files are also quite large. The PDF files have maybe like 90 plus pages, and it's a lot of work to actually go through them. Sometimes the names are also inconsistent. So maybe if you want to find some sensors, which is like temperature sensor, and it's in some place called temperature, but in another place it's called temp. And you cannot just do a simple Control F to find all of the interactions that you want to find. Sometimes the building schemas are outdated. So when a building is made, well, the building schema is written, but then it's not updated. Maybe you have a new boiler, maybe you have a new ventilation system installed, and that is not kept up to date. So in the building schema, you can find outdated sensors, maybe dead sensors, or maybe sensors that are missing, and that makes the challenge even more harder. And overall, like if you look through it, there's like from 8 to 10, hundreds of thousands of sensors that are within a building. So as one person, you have to go on site and actually map all of those sensors into a digital version. And that can take up to like 2 or 3 weeks for a client. And you can imagine how problematic that is to actually scale up for a business. So that has to be somehow solved. And what we proposed was, okay, instead of actually having the owner introduce the building schema and then the BMS operator working with it, we could introduce an AI, which is a companion AI. The companion AI could collect the measurements from the BMS system and from all of those hundreds of thousands of sensors, learn from them, figure out which ones are relevant, and then provide something like a digital twin of the building instead of the building schema. And now the BMS operator can interact with the AI and hence get the most relevant and up-to-date information, because the schema is no more relevant. Now the AI has all of the representation of the whole building, and whatever sensors there are inside, whatever is not working, well, it's not there. So this is a very nice and quick and interesting approach. So let's go through the 2 simple tasks that this AI has to solve. First one is to figure out what sensors there are in the building. So if you have just a bunch of measurements, you have to figure out what type of sensor it is. Is it a heating sensor? Is it a boiler? And so on. Is it a ventilation or a cooling? And the second part is to actually group those sensors into actionable groups called zones usually. So for example, if you have a collection of rooms that are being heated up by one boiler, and then you have another ventilation system that heats up the other part of the building, those collections are called zones. So those 2 tasks are primary to set up the new building. And we are going to go quickly kind of on how that can be done. So as machine learning engineers, you would probably look at the raw data, probably it's a signal, pre-process it, put into your favorite machine learning library, and then abracadabra, you get some results. And as you can see, it's like a heating, a cooling, and so on. But this is not something you would show to a BMS operator. In the end, he needs like proper results and somehow to interact with them. So what you do, you build a UI around it. So for example, this is a UI that we have for AIMS, still in progress, but basically it shows the results of the AI, and then the BMS operator is able to select the correct type of sensors that we are having in there. Similarly, for the zone construction task, we again have raw data. We put it through our favorite machine learning library. It could be like a clustering model or something like that. And then that would output some huge matrix of numbers. To me, this matrix makes sense. To you, maybe it doesn't. Maybe if I add a bit of colors, maybe it makes more sense now. So on the x-axis, we have like zones, and then here we have sensors. Of course, it's trimmed down. In reality, we have 100,000 sensors. And here you can see very big numbers. So those are probably like, okay, that's one group, and so on. But again, you would not show this to a BMS operator. In reality, what he wants is a UI. So you make one. First of all, let's go through what changes has happened from here to here. So first of all, we limited the number of results that is shown overall, because the human has to make actionable decisions, and well, his attention span is quite small. So what we want to do is like just present the information in such a way that is very easy to make the action. So for example, we provide all sorts of numbers which are basically explaining relevancy of every sensor to a specific zone. And it's easy to figure out what is happening here at a glance. He has only relevant sensors, so here's like 5 of them which are composed, and here's zone. And then he can use that to later compose the zone. So maybe select that these ones are correct or not, and proceed to the next zone. Oh, okay. And then what also can be done is, is to sort the results, and that it makes it just like, okay, the most confident ones are solved first, and then the least confident are solved last. But overall, if you go back to the AI maturity interaction model, this is just a pretty UI wrapped in pretty AI that is wrapped in a pretty UI. And that is not actually very autonomous. It does not solve anything by itself. And you can imagine still the person has to go through every one of those zones and figure out everything. So it's not as quick, but it is better. Okay. So let's try to make a change, just a change in terms of like how we formulate this task, how the interaction is actually happening. And instead of just having it as a, well, I have to fix or validate the AI, I will change it into a conversation. Okay. So again, we have this setup. The BMS operator selects, okay, these ones are correct. And then after that, he can trigger a new suggestion, right? And so these suggestions are sent to the AI. And now based on these suggestions, the AI can rerun the model and get it new results. So we get new suggestions. And then again, the BMS operator can select something that is relevant or not. And then these are passed back to the AI. AI is maybe retraining and then, well, improves and gives better results. And hence, we applied a few design choices that are making this interaction much more quicker, much more faster, and more reliable overall. And yeah, we switched it from a conversation, from a checking, just validating the AI to a conversation. And now all of the suggestions are also tailored to the BMS operator's vision. But we can go further. In AIMS, we are always road mapping and thinking and trying to figure out how can we do better? How can we actually apply more of these technologies? One of the examples could be using explainable AI. So maybe once the AI can explain its own decisions, provide proof or validation for why it chose something, we could let it do the whole configuration autonomously, and then the whole process is just sped up to just an instant. Just collect the data, run the AI, and gives the results. And if you want to check it later, well, it has the explanations for why it did something. Another example would be maybe doing some theory of mind. So maybe the AI could think, oh, what is this BMS operator missing that I have to tell him so that he comes to the same conclusion I came to? Or maybe backwards, what is the AI is missing such that that the BMS operators knows so that they can come to the same conclusion. And now this is just one first order theory of mind, but already this allows you to reformulate the task in a different manner, which allows you to get better results. And maybe you can also go like into the direction, so from individual to a society. So once we have this AI running, we are making an impact on not only buildings, not only companies, but also we're just making a societal impact. We're making an impact on the whole country or maybe even the whole world, because the whole world is now using less energy or CO2, hence we're making impact in terms of stability worldwide. A good question to ask yourself maybe is, do you have to go to the far top right corner of the cube? My answer would be not really, but it is nice to have a direction, a goal, where you're going to, instead of just doing stuff randomly and not knowing what you're doing. And I think this is beautifully illustrated in a quote from Richard Hamming about a drunken sailor who was traveling left and right. And he was going, ta-da, and basically, if he makes n steps, his distance from the point he started at would be proportional to the square root of n. However, if we change this experiment and put a pretty AI on one side of the line, now when the sailor is going to be walking left or right, his distance is going to be proportional to n, the number of steps he took. So basically, what this means is the difference between the people who go far and the people who stay behind is the fact that they have vision. Thank you for listening to our talk, and yeah, we're looking forward to your questions.
Who may I give the mic? Anyone questions?
Very interesting. I'm wondering, all the data from the sensors, how do you get at that? The data from the sensors? Yes. How do you get at that? Because there lies the basis, I think.
Yes, so this is part of how AIMS is set up. The AIMS chip or device is installed into the BMS system that is in the buildings. So all of the buildings are usually smart, but they're not smart enough. So what we do is we connect a device which collects the measurements from the thing, and then we also send back the AI choices that AI makes.
How much time does it take to make them more smart then? Because you said it's a lot of sensors, so I'm just curious.
Yeah. So once once the system is installed and the new building is configured, well, it can operate starting day one, basically, as soon as the new AI has been trained. So it is trained online. So once the new data is gathered, new AI has been refined. So it is trained on the go, basically.
Thanks for your talk. I was wondering, you have this axis from individual to society in the end. I understand that it's useful to go to society, like you want to have more impact, right? But how does that change the choices that you make and that the model makes? Because from what I understand with the buildings, it's more like the more people use it, the more impact it will have, but that's not really a design choice, right? That's just...
Yeah, actually, if you can you hear me? The question is like, if you go to society, is that always then the right impact that you want to have in the limited amount of time that we all have here? But I think that if you go to, if you design an AI application, and you want it to have more impact for scalability, then not only those AIMS buildings are enough. We have to do hundreds or thousands or 100,000s of buildings to give an impact on that climate management. So from that perspective, you look like, okay, we need to do a societal impact. But on the other hand, if you design your system such that it covers a broad solution, then it's often really a problem for the individual user. Here, the BMS operator. So you have always a balance between this overall impact and the real impact on the human that works with it. And you don't want to have these overall solutions every day. We are used to them now since the 1970s, and we want to have more companion or personalized interaction. Maybe behind that one, a personal AI building configuration, a companion of that operator or engineer, maybe that one can communicate with other buildings and say, for example, in that transfer learning or co-learning layer, like, hey, we did this analysis and I helped this guy with finding out how this building works, and we did it in a few minutes. So maybe you, next time when you are there, advise your operators as well. So you can have different layers of scale when you have different types of AI.
Yeah. Thanks.
Guus hiervoor.
Yeah.
And the mic to Guus.
Yes, thank you for the nice presentation. I was wondering, you mentioned that sometimes it could take weeks for a BMS engineer to get through a building and know what sensors are grouped together, stuff like that. How has that changed with the introduction of the AIM system? Has it gone down? Has it been improved? I'm just curious.
Yes, so it did improve, and it definitely has impact on the bigger buildings that are, for example, like hospitals or swimming pools. Those are very hard to configure by themselves. At the moment, also, there is a lot of clients which have smaller buildings and which are just easier to configure by hand because the BMS, schemas are small. So there is a trade-off in terms of, okay, to get the data, we have to wait a few weeks once the system is installed, or we have a small schema, then that is done by hand usually. So, but on the bigger side, there is impact, and it does help the person to actually figure out.
And can you give some sort of figure, like normally a hospital would take 2 months and now we can do it in 1 month, or don't you have those figures ready?
Unfortunately, I'm just a developer, which is I
fair
don't have
enough.
access to the production stuff,
Yeah.
unlike how much I wanted, but I can't. Sorry.
Okay, no,
It's a-
fair enough.
It's a developers conference, but the question is right. Yeah, it's a balance. You can make beautiful systems, but does it really help? But we are now in a pilot phase with people that are engineers and operators, and they have sometimes really that puzzle about, okay, how to configure this building properly. And we do have in that pilot some interaction with buildings, and the larger buildings we have, of course. But we're running with this activity, we're running one step ahead. We want to have that scale and want to be prepared for that scaledness, not only for that solution of the company aims, but also when other companies hook up their smart buildings to the power grids. And then you go up to a world where people say, okay, now we have to do these thousands buildings. Oh my God, we cannot do. That's from a business point of view, that's wrong. We must be able to do these 1,000 buildings, so we better hurry up with our prototypes and experiments on this.
Anyone else?
If there are no questions, I'd like to say hi to my mom because she's gonna watch the recording online. Привет, mom.